day everyone, this is another exciting day again, and I want you to subscribe on my YouTube channel, like it, make your comment so that we know what else we need to do. And even as I'm been walking through repairs, I want you to also ask questions, make comments so that I explain some details for you. But presently right now, I will making a video as circuit designer things. I'm already used to repair, and when you open majority of all these electronics, you see some plenty compartment, you see these electronics components filled up everywhere now, here and there. But I want to tell you how come about those circuit designers. Just imagine a board like this. Just imagine a board like this. How do they design this board? How come about these things then? And mark you, the more functions you add or the more features you add, the more the complexity of that board. Let me repeat that again. The more features you add to your design, the more complexity your circuit diagram is going to be. So let me take for example, I want to design an air conditioner panels, so you will understand something. First of all, you must understand that the light you have in your house, you must understand that the light you have in your house is an AC. So meaning you have the AC section, the power supply section, the power supply section. Now, because you have a normal electricity, this power supply is your comprises the AC, and another thing again, your voltage line is not that okay, let me make it this way. The electronics you want to design, electronics components are basically 5 volts, 12 volts, 15 volts, but the most common one used is 5 and 12. I'm talking from experience because I've been doing repairs, so 90% of circuit diagram I normally come across, or panels I normally come across when it comes to air condition panel, are basically 5 and 12 volts. If there's anyone that have 15 volts, I will tell you where they normally comes, how the 15 volts comes in. But majority modern panels are 5 and 12 volts. This is just a secret I'm just revealing. When you get to the masterclass, you will understand more on these voltage lines and more on this voltage. So, meaning this my power pack will involve a step down, because your normal light is 220 and you step that 220 down to something 12 volts, because you need 5 and 12 volts, so you go for the maximum voltage, meaning you are using a 12 volts transformer to step it down. So after the power supply, you think of it. My circuit diagram is how does an AC circuit diagram works. When you go through normal AC, you find out that one, when you on it, it makes a sound, a noise, a beeping sound, and that beeping sound, some will just make pim. When it makes that sound, the swing opens. So meaning you will understand that it has a display unit and the swing will make a move. So meaning you have the swing section or the swing circuit. After the display circuit, then the blower starts. So meaning you have the fan circuit, Now it starts and starts blowing. After some time, it transfers to the output, to the outdoor unit. That is for 1 horsepower to 2 horsepower. If you want to know why, join the masterclass. You will get to know something about that. Why is it that? Okay, let me skip that first. Now it transfers to the outdoor, meaning there is a circuit unit that transfers to the outdoor. What do we call that? Let's say we call that the output section or circuit. Do you understand that now? So these are how we design circuits. So meaning your power supply is there, the display unit is there, the swing circuit is there, the fan circuit is there, the output circuit is there. So this is how how do you link these together? Now you need something that will be telling them that this comes first, this comes next, this comes number 3, this comes number 4. That is a microcontroller. Ordinary ICs can easily do that, also, but it will take more complexity, more complex work. So what they go for a microcontroller. So they're now bringing a microcontroller section. A microcontroller circuit. So how do you assemble this together? Because you want to design this circuit. How do you assemble this together? So meaning you not do it this way. Okay, so if you say you want to assemble this, you're already aware of this. So the first thing you meet is this guy here, the power supply. So meaning you start from your power supply, now the next thing is the controller. Because before anything starts functioning, the controller must receive that signal from the power supply. So from the controller here, it tells it that, okay, straight. It takes it to the display. From the display, it takes it again to the fan, circuit. Then takes it again to what again? Oh, sorry. Before the fan, the swing. So what now comes last is the output. This is just a simple way you reason it. Now, why am I doing this idea so easy? Because I've been doing repairs. That's why I tell you that doing design, if you're already good at doing repairs, it's easy for you to reason out designs, circuit designs, because you gather what you have been fixing, how their own works, and from there you'll be able to have an easy access on how you are going to do yours. But mind you, you just only using an indicator display, not a discrete display. What do we mean by a discrete display? Discrete display is where you see the display, you see it. If the temperature is at 16, you will see it. If you increase it to 20, you will see it. These are discrete, but we are just going to work on an indicator because like I said, the more the features, the complexity of the design. But you are working with a controller, meaning the complexity of the program you are writing into this controller. So another thing you will realize that, what if the swing does not work? In repair, they don't add much emphasis on that, so it does not stop the system from working. What if the display did not come on? If the display did not come on, let nothing else function. As in, if it's faulty. But if the display is only faulty but is sending a signal, it will not still function because of the buttons. But as long as, say, the light is reaching the display, you can use the remote to on it. If it works if it's still working with the remote, fine. Meaning other things comes up. Now, those are how to also protect, because you must reason a way out to protect your system. Because one basic thing you are protecting the compressor from damaging. So that comes adding error codes, or let this circuit design detect error. Majority of them, if it detects that the fan is not working, it will not send to the output. But like LG, whether the fan works or not, it will send to the output. But Panasonic does not work. Samsung will not work, and some other product that uses 3-3 fan, 3-3 indoor fan. I will explain what I mean by 3-3. Okay, it's already in the masterclass, so you just join the masterclass, you will understand 3-3. So what else again are we designing again? So if the compressor did not peak, if it were Panasonic, you will also know. And there's another important thing I'm forgetting that I did not add in this place. I'm supposed to add something like a sensor unit, because it's an AC. You need something that will tell the ambient temperature, the surrounding temperature. So let me add sensor here. Sensor circuit. This will tell you if the house is cooling. Some can program it that if it stays for 5 minutes and it does not receive cooling, it should shut down the system. So since I've added this sensor circuit, meaning I will still add to my programming. So this is what I mean when I tell you that the more the features, the complex your design is going to be. That is why a microcontroller is perfectly okay, because it is the write-up, it is the programming you are writing that you will be doing the adding until you're not reasoning that, okay, this thing I'm doing, let's assume NEPA goes off and comes back. Will the system still retain the temperature at which you set it at? Or let's assume NEPA sees light and comes up again. Will it start on its own? That is why some will now add something like an Autostart circuit on it. Some does it internally, some link it to an EEPROM to store memories of what has been going on. Because without the EEPROM, everything will wipe off when it goes off, and you will start doing your setting again. And mind you, the white men are reasoning that Let us not make an AC that it will be work on both cool. You can also make use of the fan. You can also heat your system with an AC. But in Nigeria, I'm a Nigerian designer now, so I'm interested on only the cool aspect. So once again, these are a process. So this is just a block diagram. This is just a block diagram. Then from there, let's say I'm done with these block diagrams. There, this is the beginning of your work. The next thing you want to now do, how do you get your circuit diagram? In one of our subsequent videos, I will quickly make a sketch on a simple circuit diagram to work with this. That one not wonderful. It's a circuit diagram, but not a proper circuit diagram. But from there you will understand where and what you need to do again. So once again, this is the end of this video. You subscribe to my channel, like my channel, and make your comment, because we'll be teaching you so many things for free, and you just have to learn this technical skill even while at home as a student. So once again, my name is Robinson Egwe. Thank you.